Right. Thank you, Vibhuti. So let's talk about what hypothesis testing really is. So hypothesis testing is composed of two types. One is called null hypothesis, and other one is called alternative hypothesis. So what null hypothesis proves that there is no um, coincidence of such factors coming together to make a result. So in this case, when we are seeing movie ratings for all these websites, we will be looking into different factors that should or might have coincided in some fashion or manner that makes it instead of having a statistical basis for all of our results, it could be that is just a coincidence. So if that null hypothesis we prove to be wrong, we will be able to move on to our alternative hypothesis, which is that we believe certain factors such as rating, summary, cast, crew, director, and year of production, as well as the summary describing the whole a movie's intent would are responsible for the ratings on IMDb, which the customers are giving, which we'll be predicting at last. So that is our alternative hypothesis. So first we need to prove that a null hypothesis is false. For that, you need to look into two types of distributions to understand what kind of approach must be taken for this data science project. Should it be a statistical analysis or should be a non-statistical models that we'll be using? So we have tried to fit our data into different types of graphs, one being the uniform distribution and the second being normal distribution. So over here we have a uniform distribution simple code related in Python, which is already has a Python library called uniform. So we are importing from that. And here is the graph. So that is showing the uniform distribution of all the factors that we are looking into as part of this factor called genre. So we're just looking into one factor, that is genre, right? And the second one is a normal distribution, which is called as which is also for genre. So we're looking into genre as a factor and creating two types of graphs, one being uniform and the second being normal distributions. So as we can see, a normal distribution fits better as compared to a uniform distribution. So we will be looking into what kind of models can give us better accuracy and predictions as well as analysis for such kind of data, right? So we are looking into a normal distribution. So now to prove anything before we start moving on with our data, we would like to pre-process it and make it into a stable uh, data and clean it, right? Because we need clean data for all our next steps. So as we look into clean data, so what we will be doing here first is these are all part of getting our data set from our Google Drive. So nothing much relevant here. And the second part, right? So this is just showing what are the different features that we're looking into: cast total likes, director likes, actor one likes, movie likes, FB posters, year, duration, genre, content rating, critic reviews, and many more. Like, so those are the features we'll be looking into. So now we're seeing there is some null uh, uh, columns or cells in this data, right? So we would be removing those as a part of cleaning this data. So we are looking into all of this. So we understand there are quite a few null cells. So the next thing is we just drop it. So we drop all the null cells and thereby give us a clean data of cast, total likes, director, actor likes, movie likes, and so on and so forth. So finally, to get our hypothesis testing phase one started, which is the null hypothesis, we are looking into something called as the p-value. So p-value is a constant or a factor that if has it shows basically the relevance between a null hypothesis whether it's to be true or false. So if we want our null hypothesis to be false, which in most case we want, so that it proves that it's not a coincidence, is that the p-value should be at a very low range. It's between 0 and 1, so it should have a really low value for a p-value to understand that the null hypothesis is false, and there we can move on to our alternative hypothesis. So our p-value right here which we have calculated from dividing the two data sets into two types of value pairs, whereas the year is less than 1990 and the year is greater than 1990, so that we can do our hypothesis testing and find a p-value. So our p-value has ended up being much lesser than 1, because e power minus 35, right? So don't just look at the 3, it's like e power minus 35. So that proves that our null hypothesis is false. And now we can move on to our alternative hypothesis, which is to prove that various factors are affecting this kind of rating that we're about to see for the movies, like the IMDb ratings that we're looking into. So for that, now we have Sukanya, and she'll be explaining all the models that we're looking into as our normal high distribution fits better.
Yes, thank you, Stuti. So next we take the next set of data and assign numerical values to the columns which have object data type. Also, to get the feature columns, we need to get the ID part of the file. So we do that. We also need to find the correlation between the different columns so as to know which model will fit the best. Hence, we find the correlation and drop column which is not necessary, which is actor likes. Next, since the variables have the same scale and unit, so there is no need for pre-processing. So we plot the graphs between the different columns to see which has the highest R squared values and the lowest AIC. So after plotting the graph, we find the model which has the least AIC and highest R square is selected. There are many more columns which are dropped from the data, like example rating, movie likes, director likes, etc. A dummy columns are created so that the model can be fit into it. Uh, since we need the sum of the various columns, we find that using the next step. Next, we split since our data is ready to be modeled, we split the data into training and test set with our test size as 40% and training size as 60%. We use OLS model for linear regression and KNN. In using the OLS regression results, we find the p-value, uh, the F statistics, the number of observations, R squared, adjacent R squared, etc. Uh, After this is calculated using the OLS model, we calculate the difference between the predicted and actual ratings. So, as you can see, the difference between predicted and actual ratings is actual is 7.1 and predicted is 5.8. So the difference is 1.3. We find out the what is the mean of all such differences, which comes out to be 1. We plot this difference using bins, histogram bins. Next, the accuracy for the linear regression and KNN model will be explained by Rudraksh.
So as we can see, the accuracy of linear regression is 0.624 and KNN accuracy is 0.7889. The budget of these movies is of the order of hundreds of millions of dollars, making their box office success absolutely essential for the survival of industry. Knowing which movies are likely to succeed and which are likely to fail before the release could benefit the production houses greatly, as it will enable them to focus their advertising campaigns, which itself will cost millions of dollars. So, through the proper benefit of knowing what is going to happen, millions of dollars will be saved. And it could also help them to know when it is most appropriate to release a movie by looking at the overall market. So, the prediction of movie success is of great importance to the industry.